Hello everyone, my name is Bhumika V from 5th ISC from GM Institute of Technology, Davangere. I am here to do the problems on automata theory and computability under the title of result realization. Before going to the problem, let us know what is DFA, means deterministic finite automata. Finite automata is the computing device that will accept or reject the regular language. To accept the regular language, we require three components. The first one is the input and the second one is the compute, means to compute the given language. Third one is the output. We use finite state machine to model the finite automata. Here, the DFA M is defined by a phi tuple, means the M is the quintuple. Here the Q is the finite set of the states and this symbol is the finite input alphabet. Here the Q0 is the initial or the starting state. Here the A is the final or the accepting state, which is the subset of Q. The delta is the transition function. And here is the given example problem. For this given DFA, the M is defined as a quintuple, and in this diagram there are three states, that is the Q1, Q2 and Q3, and the input alphabet given here is 0 and 1, that is the input alphabet, and the Q1 is the starting state and here the Q2 is the accepting state. Here the delta is the transition function and we have to write the transition table for the given DFA. Here is the transition table. This is the transition table. For the starting state, that is the Q1, if we give the input alphabet 0, it will remain in the same state. And if we give the input alphabet 1, it will goes to the next state, that is the Q2 state. And for Q2, if I give the input alphabet 0, it will goes to the next state, that is the Q3. And if I give the input alphabet 1 for Q2, it will remain in the same state. And for Q3, if I give the input alphabet 0, it will goes to the accepting state, that is the Q2 is the accepting state. And if I give the input alphabet 1 to Q3, it will go to the accepting state, that is the Q2. And this is how we write the transition table for the given DFA. Let us know how the language is accepted by the DFA. What is a language? A language is a finite or infinite set of strings over a finite alphabet. And a regular language is a language recognized by a finite automation M and it is denoted by the L of M. L of M means it accepts a string or a word W where W belongs to the set of the alphabets and that string is processed with the state, that is Q, and after the transition it will reach to the final state. Here is the one method to accept the given language by a DFA. The method is the string length mod k with the relational operator. Let us see what is the general method to solve string length mod k problem with relational operator. The first step is solve the string length mod k problem connected by a relational operator has a two independent problems. Here the first step is the given problem, we have to solve that given problem has a two independent separate problems. And here the step 2 is the state Q of combined machine M that accepts a given string W is obtained by taking the cross product of Q1 and Q2, that is two independent problems has shown, that is the Q is equals to Q1 and Q2, where Q1 and Q2 are the state of the machines M1 and M2 respectively. In simple words, I can say that the state Q that accepts the given string W is obtained by taking the cross product of Q1 and Q2, that is Q is equals to Q1 and Q2. Now, in third step, we have to obtain the transition of the combined machine using the transition delta 1 and delta 2 of the machines M1 and M2 respectively. Using this formula, we have to obtain the transition of the combined machines. This is the formula. And in step 4, we have to identify the final state using the given relational operator. Now let us go through one problem with respect to the string length mod k with relational operator method. Here is the problem statement, that is, obtain a DFA to accept the string w satisfying the following condition. This is the given language. L is equals to w mod 3 is greater than or equal to w mod 2, where w belongs to the input alphabet and the input string here given is A. Solution to this problem is, we have to solve the given problem as a two independent problems, as I have mentioned in the steps, general steps. Here in problem, there are two conditions, that is w mod 3 and w mod 2. We have to solve this given condition as a two independent problems. That is w mod 3 we take this as a machine 1 and w mod 2 we take this as a m2, that is machine 2. For w mod 3 we get the reminders are I is equals to 0, 1, 2. How we get these reminders means, here the divisor means k is equals to 3, k is equals to k minus 1, that is 3 minus 1 means 2. From 0 to 2 we take the reminders, that is I is equals to 0, 1, 2. These are the reminders with respect to this machine. And for this m2 machine, the reminders we get are I is equals to 0, 1 with respect to this machine. And here the divisor is k is equals to 3 and here the divisor is k is equals to 2. Now we have to do the cross product of two states, that is q1 is equals to I means reminder, q1 is equals to 0, 1, 2, that is q1 is equals to 0, 1, 2, and here the q2 is equals to 0, 1. After doing the cross product of two states, that is q1 and q2, we get the required set of the states, that is 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. Now we have to find the transition state using the below formula, that is q delta of p comma q comma a, which is equals to delta 1 of p comma a and delta 2 of q comma a. To find the delta 1 of p comma a, we are making use of this formula, that is delta of qi comma a, which is equals to delta of I plus 1 mod k. This formula is with respect to the string length mod k problem. And previously we have obtained some required set of the states, that is 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. And here we are making use of those states. And here the first state is the 0, 0, a, that is delta of 0, 0, a, which is equals to delta 1 of p comma a. Here p means 0 and a means the input alphabet. Delta of 0, a, we get the output as 1. How means, we are making use of this formula to find the delta 1 of p comma a. Here the qi is the 0 and a is the input alphabet. We apply those values in this formula, that is q of I plus 1 mod k. Q of here I value is the 0 plus 1 mod 3. 3 how means k is equals to 3. In the given problem, there are two conditions, that is w mod 3 and w mod 2. So that here the k value is the 3 and for another here the k value is 2. After computing this, we get the delta of 0, 0, a, which is equals to 1, 1. And here the next state is the delta of 0, 1, a. 0, 1, a. First we have to do 0, a. For this we get the output as 1, that is 1. And for this 1, a, we get the value as 0 by using this formula. And for the third state, that is 1, 0, that is the delta of 1, 0, a. For this 1, a, we get the value as 2 and for this 0, a, we get the value as 1 by using this formula. And the next state is 1, 1, that is delta of 1, 1, a. For this 1 comma a, we get the value as 2, and for this 1 comma a, we get the value as 0. The next state is the delta of 2 comma 0 comma a. For this 2 comma a, we get the value as 0, and for this 0 comma a, we get the value as 1. And for the next last state, that is 2 comma 1, that is delta of 2 comma 1 comma a. For this 2 comma a, we get the value as 0, and for this 1 comma a, we get the value as 0. We get these values by using this formula, that is the string length mod k formula. After finding the transition table, we have to identify the final state using the given relational operator. The given relational operator is this, that is greater than or equal to. In the problem, there are two conditions, that is W mod 3 and W mod 2. We have to find the final state using this relation. This is the input alphabet A. Here, why we are writing this table means we have to check whether the given condition is satisfied or not. The given condition is this, that is W mod 3 is greater than or equal to W mod 2. Yeah, here the A is the input alphabet. In any string or a word W, the number of the A's should be more than 0 times, that is 0, 1, 2, 3 and so on. And we have to check this condition, whether this condition is satisfied or not. If the A is equals to 2, that is W is also equals to 2. 2 mod 3, the value I get is 2, and for this 2 mod 2, I get the value 0. This condition becomes 2 is greater than or equal to 0. It satisfies the given condition. And if the value A is equals to 9, then 9 mod 3 is equals to 0, and this condition is greater than or equal to 0. And W value is equals to 9. 9 mod 2 means I get the value as 1. So 0 is greater than or equal to 1. This condition is never satisfied. When the number of A's is equals to 3 and 9 and 15, the condition is never satisfied. That is, when A is equals to 3, the condition is never satisfied, and when A is equals to 9, the condition is never satisfied. Which condition? That is, the W mod 3 is greater than or equal to W mod 2. This should be greater than or equal to this condition. After finding the relation, we have to write the final state diagram. This is the final state diagram. Previously, we have obtained some combined set of the states, that is 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. Previously we have written the transition table. Using this table, we have to write the final state diagram. Here, the starting state is the 0, 0. For 0, 0 state, if I give the input alphabet A, it will move on to the 1, 1. We have to see this transition table. For 0, 0, A, here the output is 1, 1. And for next 1, 1, we have to see in this transition table. For 1, 1, A, the next state is the 2, it will move on to the next state, that is 2, 0. Here is the 2, 0. For 2, 0, if I give the input alphabet A, it will move on to the next state, that is 0, 1. And next for 0, 1, if I give the input alphabet A, then it will move on to the next state, that is 1, 0. Here is the transition table. We have to see this transition table and write the next state in the final state diagram. Now for 1, 0, if I give the input alphabet A, it will move on to the next state, that is 2, 1. This is the 2, 1. And here I have written two circles for 0, 0, 1, 1, 2, 0, 1, 0, 2, 1. Why means previously I have identified the relation that W mod 3 is greater than or equal to W mod 2. Here for the if the number of the A's is equal to 3, the condition never satisfied, and if the number of the A's is equal to 9, then also the condition not equal, and if the number of the A's is equal to 15, then also the condition will not equal. Here if the number of the A's is equal to 3, then the state will not accept. See here, 1A, 2A, 3A, then the state will not accept. And if the number of the A's is equals to 9, then also the state will not accept. We will see here now. 1A, 2A, 3A, 4A, 5A, again it will goes to the first state, 6A, 7A, 8A, 9A, then also the state will not accept. Except the number of the A's is equal to 3 and 9 and 15, except these numbers, if the number of the A's is equals to other than these numbers, then the state will accept. See here, if the number of the A's is equals to 1, then it will accept, and if the number of the A's is equals to 2, then it will accept, and if the number of the A's is equals to 4, then it will accept. And if the number of the A's is equals to 6, that is 1A, 2A, 3A, 4A, 5A, 6A, then also it must accept the given condition. And now here we are giving the loop to the starting state. Why means for any number of the A's, it must accept the given condition. So that's why we are giving the loop to the starting state. Like this, we write the final state diagram. This is the final state diagram for the given problem, that is string length mod k problem with relational operator. Thank you.